All right, today we're going to go ahead and we're going to talk about linear programming in advanced algebra, which has to deal with, graphing inequalities. And one thing that I want you to pay close attention to is this box up here about what linear programming actually is and what it's used for. One of the main things that I want you guys to take a look at is when we're doing this, we're going to talk about these things called constraints. And we're always going to have an objective quality, okay? The constraints are what is going to go ahead. Those are inequalities that are going to create a region that we're looking at. And then those regions are going to have vertices. And we're going to go ahead and we're going to use this thing called the subjective quantity to go ahead and figure out maxes and mins, which is what is said right here. Okay? So let's go ahead and let's take a look at how we're going to graph these problems where we have more than one inequality. Okay? So the first one right here, we have what's known as my objective quantity. That's this right here. This is my objective quantity. And these right here are my constraints. Okay? So we're going to go ahead and we're going to take I spelled that wrong. Hold on. Let me erase that. We're going to go ahead and we're going to deal with my constraints. Okay, so to start off with, what we're going to want to do is we're going to want to label my graph. So this is my x-axis, this is my y-axis, and this right here is 0. So this is my origin. Okay, so this really up here, this is quadrant 1 because your y's are positive and your x's are also positive. Okay, I'm going to take and I'm going to label this down here 5, 10, 15, and 20. I'm going to do the same thing here. 5, 10, 15, and 20. Save ourselves a little time instead of going 1, 2, 3, all that kind of stuff. Okay? So I'm going to go ahead and start off by doing my first constraint. X is greater than or equal to 1. Okay? So we know that we're going to go ahead and we're going to find my 1, and we're going to draw a vertical line. And it's greater than or equal to, so it's going to be a solid line. And we would go ahead and we would shade in this direction. It has to be greater than 1. Okay? Green equation, y is greater than or equal to 0. I'm going to go find y is 0, and I'm going to draw in this constraint right here. So we know now that we have to go greater than 0. Okay? And then the last one we'll make in my blue line, that is 3x plus 2y is less than or equal to 24. Now my thought is it might be easy is to graph this by finding the x-intercept and the y-intercept. Okay? So to find the x-intercept, we're going to have 3x is less than or equal to 24. All right, and then we're going to get x is going to be equal to 8. So my first ordered pair is going to be 8 comma 0. My second ordered pair, we got 2y is less than or equal to 24. So when we solve this one, we should get 0 comma 12 for my y-intercept. Okay, so let's go ahead and let's graph that. 8, 0. So I'm going to go over to 8 on my x-axis. And then I'm going to go up 12 right here on my y-axis. And I'm going to go ahead and draw in this constraint right here. Okay, so we have that. And it wants us to go ahead and shade below because we have a less than. So right now, I have a greater than for x. X is greater than or equal to 1. I have y is greater than or equal to 0. And I have this one, which is less than my blue line. So we're going to go ahead and we're going to shade in my shaded area. So it's all of this right here. This is where all of my arrows are pointing to. Okay. All right, and then what we're really going to look for, what we're really going to focus on here, is we're going to focus on the vertices of these shaded regions right here. Okay, so this one is at 1 comma 10. All right, this one is at 8 comma 0. And this one right here is at 1 comma 0. All right, and what we do is we take all of these and we would put them back up here to find out what my max and my min profit value would be. Okay, so you're really graphing the constraints, guys, and then substituting back in to find out what your profit margin would be, what your cost is, and you always want to know in a business what your max, your min cost or profit is going to be. Okay, let's do the next one. Okay, right here, number 1, objective quantity. We're going to use that at the end. Number 2, these are my constraints right here. So let's go ahead and let's graph my constraints. But first, let's label my graph 5, 10, 15, and 20 for my x-axis. 5, 10, 15, and 20 for my y-axis. Okay? My first one, we'll call it my green line. X is greater than or equal to 1. Same idea. Solid line. Oh. Right, and you would go ahead and you would shade to the right of this one. Okay? Y is greater than or equal to 2. We'll call that my purple line. Okay, so y is greater than or equal to 2. I'm going to go ahead and we're going to draw on this right here. We found the value of 2 for my y, and we would shade above. Okay? And then my last one, I got x plus y is less than or equal to 6. So for my blue one right here, my x-intercept would be 6, 0, and my y-intercept would be 0, 6. All right? This right here is my x-intercept, and this one right here is my y-intercept. Let's go ahead and let's graph those. All right, 6, 0, and 0, 6. Go ahead and let's draw in my line between those 2 points. All right, so I got my line segment here. And it wants us to shade according to the sign below. So I'm going above the purple line, to the right of the green line, and below the blue line. So this right here is my shaded region. Okay? Now, like I said before, we're really going to focus on these points right here. These are known as my vertices. Okay? So for part B, it wants me to find the coordinates of my vertices. So this one is 1, 5 for my x and y. I'm going to put 1, 5 right here. Okay? This one right here, it is at 1, 2. So I'm going to put 1, 2 right here. And then this one is at 4, 2 for your ordered pair. Okay? So this one has 3 vertices, obviously, because the shaded region that we created is a triangle. Sorry, let me see where I'm at. Okay, 7 minutes left. So that's why we're looking at 3 vertices right there. Okay. Now, what it wants us to do is it wants us to take and substitute these values into my cost function here. So I'm going to say C is equal to 4 times 1, all right, plus 5, and my Y value is 5. And let's see what we get. We end up with $29 for that. Okay, let's do the same thing for my second one. 4 times 1 plus 5 times 2, because that's my x value and my y value, and I end up with, 4 and 10 give me $14. And then my last one, my cost function is 4, and my x value is 4, plus 5, and my y value is 2. So I get 16 and 10, I end up with $26. Okay? So if I wanted to know my maximum cost and my minimum cost based on my amount of production or something like that, my maximum value is going to be $29, all right, and that's going to be at the ordered pair of 1, 5. Okay, and then my minimum value would be this one right here. It would be $14, all right, and that would be at the ordered pair of 1, 2. That, guys, that's how we use inequalities and constraints to go ahead and figure out, profit margin, prices, cost, all that kind of stuff. And also the region that we're going to use to be profitable or stay within cost. Okay, obviously we wouldn't go ahead and we wouldn't choose anything out here because we might not have the manpower at 15, 15 to go ahead and manufacture something like that. So this is a good model, guys, as far as what businesses use to kind of stay within their budgets and to stay within their time constraints and that type of stuff. So, all right, guys, that's linear programming. The rest of the examples I'm going to want you to do on your own.